Hi, my name is Lynn Hillenbrand, and I am a professor in astronomy here at Caltech. I'd like to welcome you to Caltech and hope to meet some of you at the Q&A session that is associated with these option talks. If you do have questions, though, feel free to email me using the address that's provided here. Now, astronomy is, of course, one of the oldest sciences existing, arguably, since humanity has itself. And shown here, if you remember your Greek mythology, is the god Atlas holding up the celestial sphere, which has some reasonable representations of the Earth's equator and the northern and southernmost latitudes of the sun, as well as the tilted ecliptic there. And Atlas is flanked by astrology and astronomy, and you can figure out which one is which by the astrologers, of course, waving the hands, and the astronomer is taking careful data and recording science about the universe. On the other side of this building is also Gaia, the Greek goddess Gaia, holding up the terrestrial globe with geometry and geography as the flanking statues. And I've always sort of liked this as just a nice reflection of philosophy. Now, fast forward to modern day, and we have the Cahill building. No statues on the roof here, but this is where the astronomy faculty are located, as well as the physics faculty, whose research happens to be in astrophysics. And so we're all co-located in this building on the south side of California Boulevard. This is where we would teach our classes in person, as well as we have public lectures and other events that happen in the auditorium. There's also a basement set of labs that are used for astronomical research instrumentation. Here is our front page of our webpage, so you can find some information here, some of which I'll review today about the academic program and about the research that goes on in astronomy and astrophysics. And here is the webpage that I maintain as the option rep, so there's a section on information for undergrad students, as well as some links to other Caltech resources. Talking specifically about the option, these are simply some clips from the Caltech catalog of the courses that we offer, and I'll highlight a few of these. First of all is AY1, which is the Astronomy for Everyone course that satisfies the freshman menu requirements. So if you have a passing interest in astronomy but aren't necessarily interested in major or minor components that we offer, AY1 may be the course for you, but as part of our main curriculum, there are these two highlighted courses called Basic Astronomy and the Galaxy, and then Other Galaxies and Cosmology. So that is the sophomore required courses for the astronomy major as well as the minor. And in the upper level, we have AY101 and AY102, which are respectively Physics of the Stars and Physics of the Interstellar Medium. And these four classes, AY20, 21, 101, and 102, are the core components of our major in astronomy. The other classes that you see here are electives of various sorts. And then during the senior year, you also have the graduate level courses open to you. So these courses, AY121 through AY127, are graduate level courses. They are required for our first year graduate students, but they're open to seniors, sometimes juniors, also as electives in upper level classes in astronomy. And here are, again, some additional electives that you may be interested in as a more senior student in our major. So that's just a review of what we have in the catalog. How is the major actually structured? Given that large menu of courses that I just showed you, what do we actually require? So that is highlighted on this slide, which again is just a clip from the Caltech catalog. But it includes in the top line the sophomore mathematics and Math 2, Math 3, as well as sophomore physics So that's either Phys 2 or Phys 12, A, B, and C. So that's your physics and math basis as a sophomore. And then as a sophomore, you would also take AY 20 and 21, those core courses that I just mentioned. As a junior, there's a physics sequence, which is Phys 106, A, B, and C, as well as Phys 125, A and B. So that's a junior physics sequence, as well as the Astro junior courses AY 101 and 102, again, that I just described on the previous slides. In addition to the physics, math, and astronomy, we also have communications requirements, like all options do at Caltech. And for us, they are satisfied by AY 30 and AY 31, which is oral communication, written communication. For the oral communication, there's also the option of AY 141, which is actually also required of our first year graduate students, but it's a seminar series where students give presentations about current research in astronomy and astrophysics and listen to and critique other students' presentations as well. So that is also available to undergrads. Better as a more senior student when you appreciate all of the astronomy that's being discussed. So that's the astrophysics core line. And then we also have a lab requirement, and that's satisfied by taking 3 lab courses from among a set of options. A popular one for our students is AY 105, which is the astronomy specific lab course. And I have a picture in a few slides of students engaged in that course, but there's required lab work. Again, similar to the physics major, fewer labs. Physics requires more labs than we do. So in addition to the core physics, math, astronomy coursework, as well as the lab work, there are a number of electives that are required. And so for us, some of those are within the option of astronomy or physics electives, again, shown on some of the previous slides where you can see the menu of all available electives. And then listed under number 4 here, we also require electives that are outside of physics, math, and astronomy. So looking to broaden your horizons in science and engineering beyond just PMA. Something that is new this year is that we are now offering the ability for students to minor in astronomy. So not just the major option, but a minor option, where the major option would be something else across campus. And this is something that we have discussed for a couple of years now, and the interest arises mainly driven by students who come to the astronomy faculty and are interested in the research opportunities in astronomy and want a little more of the academic background to go along with that, as well as true minor concentration and study. So we've developed the minor ability to have a minor in this option, and it is somewhat similar to what I just described for the major in terms of the astronomy, but it has somewhat less of the physics requirements, essentially no required physics beyond the sophomore Phys 2 or Phys 12, and none of the upper level physics as required, though it's certainly helpful in appreciating the astronomy. So the outline of the minor is that we have this basis in physics, which is again sophomore Phys 2 or Phys 12, and then also the sophomore astronomy, the 20 or 21 that I described earlier. And as another option for this, there's an AYGE 11C, which is formation of the solar system, that has been proven quite popular with students. So 2 of these courses are required at the intro astronomy level. And then the in-depth, more junior or senior courses in the minor are again this AY 101 and 102, which is also a core for the major, or some of the other electives that are also open, obviously, to majors as well. So the minor lets you choose among these options, taking 2 of these more advanced courses, and then a significant component of the Astro Minor is the research component. And so here it's one term, 9 units of required research, and then another 3-unit course that would be essentially writing up the research, either in a, maybe writing something up that would satisfy a communications requirement. One of the questions we often get is, what are the differences between being an astronomy major and being a physics major? And in fact, they're quite similar. The astro major does require a lot of physics and physics electives. And the main difference is what we require are fewer of the physics labs. So if you look at the physics option requirements, there are more labs that they have. We replace that with these required astro courses. So there's room in the calendar or the schedule for these required courses, and these also can be counted as physics electives. So if you were to go the physics route, you can still take some amount of astronomy, not as much of the astronomy electives, obviously, but they are, we have students who major in either astro or in physics and successfully go to graduate school in astrophysics or astronomy. So beyond just what is in the catalog as the requirements for each of these options, in practice, some of the differences are that the astronomy classes are typically smaller. The number of majors we have per year is usually 4 to 5. It can be only 1 or 2, it can be 8 or 9, but 4 or 5 is a typical number, and therefore the upper level classes are quite small, having mainly the astronomy majors as well as interested physics majors. The intro level sophomore classes are a bit bigger, but usually no more than 12 or so. So the classes are smaller, and the schedule, and I'll show an example schedule coming up, but there is room in the senior year within the astronomy major to do research work or a dedicated senior thesis all throughout the senior year. And there's also opportunity to take the graduate level classes. So the major is a little bit front-loaded in terms of work in the sophomore year and junior year, but the senior year is pretty open for electives and research. In addition, because the number of majors is smaller, the ratio of undergrads to faculty is favorable from your perspective. And there are lots of opportunities to get involved in research, either during the academic year, for example, as part of the work study program, or under coursework. If you take AY 142, that's a research course that will count for academic credit for research. And we have a lot of great research opportunities, whether during the academic year or over the summer. And here is a group of students from a couple of years ago in one of our lab courses. This is from AY 105, which is Optics and Instrumentation Lab. And so we do have some hands-on work with instrumentation in some of the courses, particularly AY 20 and definitely AY 1. We try to take trips each year up to Palomar Observatory and maybe up to Mount Wilson. Now here is an illustration of how all of this various coursework aligns within a realistic schedule. And so you can see the number of units total at the bottom is 45 or 48 for each of the quarters during sophomore, junior, and senior years. And again, this is just illustrative of how the various courses can combine into a realistic schedule. Also leaving plenty of room, of course, for your humanities electives, the HSS requirements, so 1 a quarter or so, as well as some electives choices to satisfy the astro requirements. So again, just an illustration that this does all work out. A good question is, what can I do with my astronomy degree? And at Caltech, a significant number of graduates from all options do continue on to graduate school, and that's true in astronomy as well. About half of our majors go on to PhD programs in physics or astrophysics, astronomy. Some of them increasingly over the past few years, I think, we've had an increasing number of students stay on after finishing the bachelor's degree to do what's called a post-bac year, so post-baccalaureate, where they may continue to do research with a faculty member at Caltech or a research group at Caltech before going to graduate school, before applying again the subsequent year. So a break from the academics to focus on research and then decide whether graduate school is really the right choice for them. But overall, about half of our majors do go to grad school. Some go to other graduate programs in, for example, science policy or science education. And then, of course, the remaining approximately half find employment. And it's mostly in some kind of software, hardware, tech fields, and I've listed a few examples here. We can compare the Caltech statistics that I just gave you about half graduate school, half employment, to the national statistics. These are figures from the AIP, which is the American Institute of Physics. And you can see, looking on the left, that it's about half and half again, half employed, half going to graduate programs of various sorts. And on the right are kind of different sectors among those who find themselves either at universities in grad school or employed. So it's a little finer breakdown. I want to say a little bit about the research opportunities that are available in astronomy, and I'll do that by showing a gallery of many of our astronomy faculty and also the physics faculty who have research interests in astrophysics. So again, these are all people located in the Cahill building. You may see the physics professors as part of your core physics or upper level physics work, and the astro professors, again, as part of the basic astronomy or upper level astronomy courses. But of course, all of these people are meaningfully engaged in important and world-leading research in various ways. So I'll describe just a little bit of some of that right now. This is an illustration of the electromagnetic spectrum, and I'm sure you've all seen versions of this plot before. In this illustration, it's going from radio wavelengths down over towards the left, and then increasing frequency to the right, decreasing wavelength, so going radio to infrared to visible to ultraviolet to X-rays to gamma rays, and Caltech professors and facilities in which Caltech has involvement span this electromagnetic spectrum and extend beyond the electromagnetic spectrum to other indicators of astrophysical phenomena like gravitational waves most prominently, as well as other particle astrophysics and other means of learning about the universe. And so what's illustrated here in pictures are just a number of the facilities that Caltech has been involved with over the years. This is showing an aerial view of the Palomar Observatory, which is, of course, tied to the very beginnings of Caltech and astronomy at Caltech. So this was being built in the 1930s and commissioned in 1948 as the world's largest telescope. And that's the 200-inch there in the center, and there are various other telescopes around the mountain that are all still in use today in various ways, taking great data. So this is a part of our history, part of our present, very much so, and part of the future of astronomy at Caltech. This is the 48-inch telescope at Palomar. It was one of the telescopes located off to the side in the previous view, and this has long been known as the Finder telescope, if you will, both for what else happens at Palomar, but also astronomy around the world. It was the site of the famous Palomar Sky Survey that was conducted in the 50s, 60s, 70s, 80s, and today houses the Zwicky Transient Facility, ZTF, which is monitoring the sky, basically taking a new image of the sky every couple of nights and looks for moving objects and transient objects, exploding objects, etc. This is a view in the upper left inside the Palomar 200-inch control room. So this is a quite crowded evening where there's a commissioning of a new instrument going on. And in the lower left shows the telescope itself. So again, although these telescopes have been around for many, many decades, they're still doing cutting-edge frontline research at Caltech, and undergrads have the opportunity to go here and get involved in this research. The current flagship facility is the Keck Observatory, so that's shown in the lower right, the two twin Keck 10-meter telescopes on Mauna Kea in Hawaii. On the left is a human, obviously, standing next to one of the instruments, so the telescope in that picture is off a little bit to the right, but the beam comes out, this instrument is inserted into the light path of the telescope and collects data. And again, there are undergrads who do surf projects working with data from these facilities. In addition to the optical facilities we've just been talking about, there's also radio astronomy, and this is a picture from Owens Valley, a little bit east and north, so it's about a 4-hour drive from Caltech, but graduate students and undergraduates, again, can go to the site and get involved in some of the research that's going on there. And going outside of the electromagnetic spectrum now, these are the two sites of the LIGO Observatory, detecting gravitational waves. For a long time, this was a physics experiment to get the hardware to the point of operation and successful detection of signals. For the past couple of years, of course, what is being observed are astrophysical phenomena, and so LIGO is now an important part of astrophysics. And again, there are opportunities for students to do, in particular, summer research projects, either with LIGO Lab itself or with some of the astronomers who work on electromagnetic follow-up of these gravitational wave signals. And finally, Caltech, of course, has a huge presence in space astrophysics, and so shown here are some of the science and hardware. Particular, currently operating as an X-ray mission called NuSTAR. Caltech, through its astrophysicists, also has a significant presence at the South Pole, doing cosmic microwave background experiments of various sorts. In the middle, on the bottom, is shown hardware development, which happens both on campus and at JPL. And in the lower right is an illustration coming from some of the theoretical simulations that go on here at Caltech. And so just to finish up, this again is our homepage for the Caltech Astronomy Department. You may find useful information here, but send me an email using the address on the first page if you have questions, and I will see some of you at the Q&A session on the 23rd. Thanks for your attention.